Let's try to understand will message and wildcard in MQTT with a simple example. MQTT last will and testament or LWT death message is a message the broker publishes automatically. In case if ESP loses power or Wi-Fi drops or code crashes, the broker will publish this special message to notify other subscribers that the device is offline. It is useful in IoT status monitoring. We'll try to understand this with the help of a simple example. A full node IoT node with advanced MQTT features is developed here. DHT11 is connected to GPIO 16 while MQ2 sensor is connected to analog input and ultrasonic sensor is connected to one of the digital input. Now let's understand the wiring. Here DHT11's data pin is connected to GPIO 16, LED is connected to GPIO 17, MQ2 gas sensor is connected to an analog input GPIO 34, and ultrasonic sensors trigger and echo pins are connected to GPIO 5 and 18 respectively. Let's try to understand MQTT topic structure. As can be seen, BVG/ESP32 is the namespace which is common in every topic. We have sensors, so there are topics related to sensors, MQTT sensor, DHT11, ultrasonic sensors, topic for LED, and topic for status. Status message indicates the status as online or offline. We can come to know about ESP is online or not using the status message. When you need data related to all the topics, you can use a wildcard by using this symbol. Let's try to understand how this is done. Open MQTT Explorer, click on Connections, add the HiveMQ as the broker. Now for the wildcard, we will be adding the details of our topics. So VVG slash ESP32 slash, we need all the data. So we are making hash. Now copy this data, go to advanced. In the advanced state, you add these topics. We are adding the wildcard so that we need information about all the topics, and now press connect. Now after connecting, you will see that you reach to the topics. So you can see that all the topics are now available for all the sensors. It is showing that your ESP32 is online and you have data related all the sensors available with us. In order to visualize the sensor data in graphical format, let's click on the symbol of a wave in front of every data. Let's say DHT11, then gas sensor data, then you may click on the ultrasonic sensor data, and you can see the graphs coming onto the screen. You can adjust the position of the graph so that you can visualize all the graphs properly in the space. Now you can see all the graphs. You can even watch the variation in every parameter over time if you continue to change the parameters at your end. So live changes in the sensor values can be visualized on these graphs. Now we'll try to understand the status message. At present, you can see that the status is on. Now at my end, I will try to disconnect ESP32. Once the ESP32 is disconnected, the status will change from on to off, and we can visualize it on the screen itself. You can now see that the status has become offline. Now this message is created by the broker. It is not ESP32 which is sending the message, because ESP32 is already off. So this message helps us, or is called as the last will message. And this helps us understanding the status, or it allows everyone connected in the network to know that this particular node, this particular sensor node is out of power.